Hello again, everyone. As promised, I'm going to keep this short and sweet. Okay, so example, pardon me, 11a. We need to write both a cosecant and a secant equation for the graph below. Think about when we had to write a sine and a cosine graph, equations for a given graph. We had similarities. The a, the b, and the k were the same. What changed was the h value because it depends on our point of reference for sine and cosine. Where did we start? Alrighty, so first thing I'm going to do is I'm going to sketch in a curve showing where my max and my min are. Makes sense. We talked about how the maximum points extend up and then the minimum extend down. So there's our curve, right? First thing I want to find is the a value, and the a value comes from the amplitude. So we're looking for half the distance from the max and the min, or you're looking for the distance from the midline to the maximum or the minimum. In this case, our amplitude is 1, which means that our a value is 1. This is going to be the same for secant and cosecant, okay? Same reasoning from sine and cosine. The next thing I want to identify is the period, because that'll help me figure out if the b value is 1 or if it's something different. So if I start on our y-axis and I travel to the right, I have a parabola opening down, a parabola opening up, and then the behavior begins again, which means that our period is pi. Thinking about cosecant and secant and their reciprocals, their parent function has a period of 2 pi. In order to change that, we'd have to divide it by b. If we cross multiply, we find that b is 2. Again, this isn't going to change regardless of secant or cosecant. And then we need to identify if there's a k value. Whoopsie, still on the highlighter. That comes from our midline. Our midline is at y equals 1, so you guessed it, we have a k value of 1. All right, let's write out the equations. First, I'm going to do cosecant. Cosecant is the reciprocal of sine, so I'm thinking, I need to find a spot where the sine graph intersects the midline, or where the vertical asymptote intersects the midline. So that means I've got that location, that location, that location. I've got a lot to choose from. In fact, let me put it in a different color so it jumps out a little bit more at us. Okay, we've got here, here, here. And remember that sine goes up from where it intersects the midline. So if we don't want to have to think about a reflection, we want it to go up. Well, that's not that middle part, right? It's this one right here. That guy. So let's go ahead and for our first choice, let's say that h is pi over 2. That's going to avoid any sort of reflection. So we'll say y is equal to a is 1. So cosecant of b is 2. Another parenthesis set because we're not distributing the b value. Theta minus pi over 2, and then k is 1. Well, some of you may be thinking, Patterson, it also intersects right there. You're correct, but it goes down from that point. So if you'd like to use h as 0, which you absolutely can because it does intersect the midline at 0, we have a vertical asymptote there, you could say that y is equal to negative cosecant of 2 theta plus 1. You just need to make sure you add in that a value as 1. Oh, no, as negative 1 because it goes down from that specific location. Okay, there has to be a reflection. Now, we were also asked to write an equation for secant. Sidebar. These aren't the only two possibilities. There are others. These are just the two examples I'm giving. Okay. All right. For secant, cosine starts on the y-axis at a maximum. So we could use this point. We could use this point if we didn't want a reflection. Let's go ahead and use this one for our h value. This would be pi over 4, making this 3 pi over 4. So our first possible answer is going to have an h value that's 3 pi over 4 radians. Here we go. We've got y is equal to secant, b is 2, another parenthesis because we're not distributing the b value, theta minus 3 pi over 4, and then we have plus 1 on the outside. But let's say you really like negative a values and you want to start at a minimum. Well, that causes a vertical reflection, so let's go ahead and choose the first one. I'm going to say that h is pi over 4. So I'm going to need a negative a value. I'm going to have 2 as my b value because remember, a, b, and k don't change. And then I'm going to have a second parenthesis, theta minus pi over 4 radians, and k is still the same. So a couple of possibilities. Again, those aren't the only ones, but just make sure a, b, and k are consistent. Okay, we also looked at cotangent today. First thing that I notice is that this graph is increasing from left to right. We talked about cotangent decreasing from left to right. So before I do anything, I'm going to say that a is negative 1. Next thing I need to do is identify my starting point, that central point. And it looks as if I'm right here or I'm right here. Okay, either one of those will work. I'm going to choose, let's be fancy. Let's choose the left. I'm going to choose the point of negative pi over 12, comma 2. Similar to when we wrote a tangent graph, this tells us that h went left, pi over 12. Ooh, wait a second. I'm in the tangent brain. Pause. That is not true. Does, how many of you are like, Patterson, that's not right? Good for you. We don't start at 0, 0 with our central point. No, we start at, pi over 2, 0. That second tick mark. So let's start from scratch, shall we? We've identified the reflection. We've identified the two potential starting points. But just for cotangent, I'm going to go ahead and sketch in 1, 2, 3, 4. What this would look like without, there we go. Okay, so notice we have definitely a reflection. It could be vertical or horizontal. I'm going to choose vertical. We have a starting point that shifts to the left or to the right, depending on which one you chose. I'm going to stick with my normal, my original, negative pi over 12, comma 2, which means I go 1, 2, 3 units to the left. We went 3 units to the left. Each unit is pi over 12. So I went to the left 3 pi over 12 units, which is negative pi over 4 radians in reducing. Okay, we also went up. We went up 2 units. Hopefully y'all are still with me on this one. Sorry about that start. You could have shifted also, let me erase some of my arrows here. If you chose to shift to this point, which is pi over 4, comma 2, we would have shifted over 1 unit, which is just pi over 12, and up 2. Either's okay. All right, choose the reference point and go from there. All right, so back to here. We have h and k. We know that a is going to be negative, but we need to figure out if we have a vertical stretch or compression. I go over 1 unit and up 1 unit, over 1 unit, and down 1 unit to get to those next points. So a is 1 times a negative 1, just negative 1 for that reflection. Whoo-wee! Last but not least, the period. The period goes 1, 2, 3, 4 tick marks in length. Each tick mark, like we talked about, is pi over 12. So the period is 4 pi over 12 radians, which equals 3 pi, no it sure doesn't, which equals pi over 3 radians. Thinking about cotangent and tangent, they have a parent period of pi. We divide that by b. This tells us that b is 3. All right, we have all the information we need, everyone, so let's go ahead and put it in. Y is equal to negative cotangent. B is 3. I need a separate parenthesis set here. We get theta plus pi over 4 minus 1. Now, if you chose the point on the right, you should have y is equal to negative cotangent. B is still 3, but now, oh, and that should be a 2. What is wrong with me? Don't answer that. There we go. Now, we went 1 unit, so pi over 12 radians to the right, and we have plus 2. Either one's acceptable. Make sure that your A, K, and B are consistent. It's that H that we're going to shift. Alrighty, Roo. Thanks, everybody. Have a fantastic Wednesday. I hope you watch this before Friday. Oi. Bye.